Well, I'm glad to be here. This is my second trip down to Australia, both of them thanks to Renewal. Okay, it's interesting to hear that Australia is forward-looking in terms of technology and is interested in doing these kinds of things. I'm going to talk today about a view of legacy systems, okay, which says that these things are important to what we do, all right, and that you need some way to manage them. And I'm going to try and explain to you, if you have the right perspective, you can build tools to help you deal with them effectively. And that's kind of what the talk is about. So I'm going to talk a little bit about sort of the background, okay, what legacy systems are about, all right, and then how tools can help you do this more effectively. Let me see if I've got the direction on this right. This is south of the equator, right? So the Coriolis force is right or left. Ah, we got it on the first try. Okay, so good. So the question is, so who is Semantic Designs? Okay, we're a small company based out of Austin, Texas. Okay, we're about 8 people. Okay, we service projects for the U.S. Fortune 500 companies and maybe some now here in Australia, we hope, in the near-term future. Okay, we've been doing this for about 10 years now based upon a technology I'm going to talk about in more detail. Okay, the talent that we have, okay, are people that have a vast amount of experience in the technology that underlies these computing systems. These are guys that have been around for 15, 20 years building systems. In particular, they tend to have, PhD level talent, okay, or high-end master's experience, lots of experience. Okay, myself, I've got way too many years. I've actually built computer software back in 1968. Okay, so far back, it's hard to remember at this point, right? And we fundamentally offer a single engine for helping people deal with large-scale systems called DMS. It's an unusual engine, okay, in the way it uses. Okay, most companies have lots and lots of tools, okay, or services or things that help. We have one engine that we use. And I'm going to talk about how we use that engine, okay, to help deal with these kinds of systems. Okay, these kinds of tools help a lot with automated systems or with IT systems, but they don't do everything. There's a creative component to any system that you build, and the tools don't do the creative part. Okay, and so we don't solve problems by ourselves. We solve problems with partners like Renewal. So we work with system integrators, okay, to achieve solutions that are effective. Okay, well, the first job that I had, okay, is I built an operating system once upon a time. It was like 1971, and I worked on it for a year, and then I spent 5 years maintaining it. Okay, and when I went to graduate school, okay, all those professors, all those software engineering guys wanted to teach me how to build new stuff. And I was never interested in new stuff because all I ever had was old stuff. Legacy means successful. It means it's been around long enough, okay, to become an institution, okay, in the organization, in the society. It's important. Okay, it establishes rules by which the rest of the world runs. Okay, that's the good part. Okay, it provides all kinds of background. It provides social context. Right. But like many things, there's some work we have to do with it. Okay, it requires continuous support to enhance it. If you look at the way governments work, okay, we use them for society. Okay, but there's a parliament that continues to run and make new rules. Right. So in order for a legacy system to be successful, we have to continue to enhance them. Okay, so they're important, but they require enhancement. There's no way to avoid that. Right. They're made out of older technologies. This is a necessary case. Right? If you have a system which is 10 years old, it's not made out of last year's technology. If it's made out of last year's technology, it can't be big enough and be interesting enough, okay, to be involved as a major subsystem in your corporation. So any successful system that you see is almost always going to be made out of legacy technology. Doesn't matter what you're doing. You build it new now, 10 years, it's legacy stuff. Now, there's a whole bunch of problems with legacy technologies. One of them is that it's usually not supported as well as the newer technologies are. Okay, all the computer vendors want to sell you something new. They don't want to sell the old thing you already have. Right, so you can't get good support for it. Usually you can't find people to support it very well. Okay, they all want to move on, or in some cases, we'll talk about a case in which people actually retired, don't want to do this anymore. You usually don't understand the architecture of the system. Okay, it started off looking like that. It was really simple when it was first conceived, and over 20 years, people have decorated with lots and lots of stuff, and it no longer looks like that anymore. Nobody actually knows how it's organized at this point. So it's a question of how do you figure out what's going on inside the system? Right, so there's a wide variety of problems having to deal with the technology, but it's important to deal with the technology because the systems are important. All right, so what happens with these systems is over time people work on them and they enhance them, they add new features, okay, try and tune them, they put them on new hardware. Okay, they start off in some initial state okay, in which they're relatively maintainable according to the original design. And over time, people add things to it, okay. The management has some ideas about direction they want to go, and they jerk the IT team around, they change things around. The technology changes, and what happens to the maintainability system goes down, okay. And everybody in this room is somewhere here on this curve, okay, and they're all concerned about being here on this curve. And the real question is, how do you avoid that? All right? The systems are important. You don't want to end up at this point where you can't manage it anymore. All right? As far as I can tell, in every large organization, the people high in management was worried about people arriving here. How do we make the system maintainable? How do we move it forward? How do we manage to respond to the business needs of the corporation? Okay, well, we're going to talk about the kinds of things that one might do to deal with this decay. Okay, one kind of thing is heroic renovation. Right? You might go through and re-engineer the system from scratch, replace all the technologies, put in modern interfaces, redesign the whole thing, construct a new architecture, build new APIs, and you want to do all this at once. Okay, migrate off of platforms. Okay, these are really, really big tasks. Okay, you can do them. Sometimes they're important to do. Okay, if you're like me, you should be scared of picking up the world. Right? It's a big, big job. Another thing you might do is to look at your systems you have more carefully. Right? You've got a lot of detail in there. The people that used to know how the system worked are gone. Okay? In essence, if there was a design of the system, you don't remember it anymore. Your organization doesn't remember it anymore. If you're going to deal with these systems in some sense, you need to be able to look at it more carefully. You need help in looking at the thing because they're large systems. When somebody has 20 million lines of code, you can't expect anybody to know what's in there. You need a way to look at it better. Right. A last big issue which is important is essentially getting at what those systems defend. Okay? I mean, I didn't understand what the word data processing meant when I first learned about it in the 60s. Okay? I do now. Okay? These are called data processing systems for a reason. It's about the data, dummy. Okay? People have giant IT systems. They have vast amounts of data which are inside them, okay, which make the corporation go. The code's kind of an incidental. It's a really important incidental, but it's about the data. The problem is the organization doesn't work well unless that data is spread across the organization as a whole. How do you get at that data? And the problem with the legacy systems is they have the data tend to be locked down inside where you can't get at it. The whole SOA movement is by and large about opening those systems up and trying to make that data available. So open the bank vault, get inside, and get at the gold. So we're going to talk about examples of each of these, okay, later in the talk. I just want to give you some background. Okay, how do you respond to the decay that shows up in these systems? And there's a number of different ways you can do this. A lot of organizations, we hope they aren't in this room, okay, respond to us in sort of an ostrich style. Put your head in the sand and just hope it doesn't get any worse. Okay, it's amazing how many companies we see that do that. Right? What that normally means is eventually they end up doing one of these other techniques, and they usually end up doing it in kind of a real big hurry at some point. Okay, they don't do it very well as a consequence. If you're going to deal with decay, you want to manage it. You want to make sure it doesn't surprise you. So you want to try and respond in other ways. A second kind of response is, let's replace this thing. Right, we've got this giant system. It's a big headache. The technology's a headache. Let's dump the whole thing and put a whole new system in place. Let's go out and get a COTS system to do this. That's a nice idea. Okay? Almost everybody with a large IT system cannot find a COTS replacement for it. You don't see COTS governments. You can't buy a government off the shelf to run your country. Everybody customizes enormously for their context, for their business, to make them more effective at what they do. You basically will not find COTS to replace your entire system. It isn't going to happen. A second way to replace it is what I call the Mumbai method of migration. Okay, we're going to take our giant piece of software, we're going to farm it out to some offshore country, okay, which happens to have a place in it called Mumbai. We're going to give a line of code every Indian in Mumbai and tell him to convert his line of code, and we're going to be done in an hour. Okay, this technique does not work. Okay, and it doesn't work for a fundamental software engineering reason. People that build big systems interact with each other. They're engineers. And when you have an interaction between engineers and engineers, you get n-squared interactions. 10 million people in Mumbai, if you take n-squared on that, your interaction ratio is enormous. Okay? Basically, these kinds of migrations tend to fail